Hello, everyone. In this video, I will give you a guide and tips for chapter 11 of my Java book. Chapter 11 is on inheritance and polymorphism. The first section, introduction, this section, and it gives the motivation on inheritance. In the next section, we introduce the notion of superclasses and subclasses. So here is the example we use in this chapter is the geometric object. It's the superclass for the so-called class and the rectangle class. We define the geometric object that models the common features for geometric objects. And we specialize in so-called. So-called is a subtype of geometric object with additional properties. And this is the rectangle is a subtype of geometric object with additional properties for rectangle. So when you define this subclass, we use the keyword extends. So here, public class, so-called extends geometric object, and geometric object is a superclass, and so-called is a subclass. So here's a test program using this classes. So you create a so-called object. You can invoke the methods defined in the superclass in the geometric object class. So this is get color, and that is in the geometric object class, and toString is also defined there, and so that's here is invoked. And for radius, and you can get the radius and for a circle and get the area, and so this is to get diameter. Circle dot get diameter. So the keyword super refers to the superclass. So please recall that we also have the keyword this. This refers to the calling object itself. So you can use super and here in two ways. And one way is to refer to the superclass method. You can call it. And or you can use this, refer to a superclass a constructor. So look at this example here is the so constructor chaining is, so when you write the constructor, the code like this, it is actually same as you are invoking the superclass NOI constructor. So if you have this constructor with arguments, and this is the same thing, you still have to invoke the superclass NOI constructor. So if you don't specify, you invoking a superclass constructor, so the default, the NOI constructor from the superclass is invoked. So, and here, it's a very important concept of the constructor chaining. So when you construct an object of subtype, it actually goes to invoke the supertype as constructor. So this is the constructor chaining. as you see here. So you invoke this faculty. Faculty is employee, and here is in the employee you have this, and invoking this employee is another constructor, and here the employee here invoke the person. Employee is a person here. Calling superclass method. So here, if you have this print circle, we have this is the circle you invoke super dot get date created. So this you can use super, but the super can be omitted if there's no ambiguity. So this is get date created. It's already defined in the geometric object. That's the only place it's defined. So it the super dot can be omitted. Overriding methods. So we have the toString already defined in the geometric object. Now you're going to redefine it in the circle class, and this is called to override. So to override it, and now you need to have this super dot specifically here, return super dot toString. That toString is from the geometric object class. If you don't have the super dot toString, just put a toString here, it's going to be invoke this toString just recursively, and which is wrong. So that's called overriding. Overriding is you redefine the method that is already defined in the super class. You redefine it in the subclass. So now we have those two terms. See, what's the difference between overriding and overloading? So overriding is for the inheritance. So the method is redefined in the subclass. Overloading is you have these two methods with the same name, and they have different signatures. So that's overloading. So we have here examples on overloading, and this is the Java has this class called the object class. And this class has this method, toString method. So every class, when you define it, if you don't explicitly extend a superclass, by default, it extends the object class. So here's object. So now you see object is the root of all the classes. It all goes to this object. So this method toString is defined object. So that's available in every class. And so normally you override it and provide a meaningful descriptive string and return from this object here. The toString here, you can have, this is toString, we have it defined in the geometric object. This is actually is to override the toString defined in the object class. All right, so polymorphism. And here you can see it from this example, it's writing this code here, is you have this display object. So here, and this, what is this object? This one is a geometric object. So here's geometric object, is this an object here, object. You can pass this is a circle object, you pass it's a rectangle object. So there are all geometric object. So this is polymorphism. Polymorphism is a Greek word, means in many forms. So here's the object can take any geometric object, whether circle, rectangle, or other geometric objects. So this is here, that's called a polymorphism. So now let's see a related feature is dynamic binding. All right, so now with this polymorphism, so we have this dynamic binding as this is the example. You can see it, we have this, the main method invokes M and with different type of objects. So what is the M here? M is object. So here is X dot toString. Now we see what is this toString. So here toString is defined in the object class, in the student class, in the person class. So here for graduate students is here, graduate student, extend student, and this is the toString is invoked for this graduate student. And this student is here, student's toString is invoked. This person and person's toString is invoked. This object toString is invoked. So this is called dynamic binding. Depends on the actual object when it's executed. So the Java virtual machine will bind and the correct method and for this invocation. So that's called dynamic binding. Now, sometimes you need to test the real type for an object using the instance of operator. So this is instance of is all in lowercase. It's a keyword. So here, and so here's the example here. Look, this is there's some method here we're going to invoke here. And this is the argument, my object. If my object is instant circle, then you can invoke this. You can cast this, my object, into circle and invoke the get diameter method. So here is a test program here. So we're going to do display object. It depends on the object. So if it's circle, we're going to invoke the circles get area, get diameter. And if this here, this object is instance of rectangle. So we're going to cast it into rectangle, then you can invoke a rectangle's get area here for this. All right, now you write a lot of code here. There's a new feature we can use from the we got to there's a so here you're gonna see this is you do a lot of this object instance of, and we can actually rewrite it. There's a new feature in this, the in I think it's Java 15 is you can specify a binding variable. Okay, so you don't have to do a casting. See, you do a lot of casting here. So look, you do a lot of casting. So here, you do a casting here. Now, we can have a binding variable writing it this way here. If object instance of circle, so here is a binding variable, is for circle, you just say circle dot get area, circle dot get diameter. And here, object instance of rectangle, here we'll give a binding variable rectangle. So this is a new feature in Java, I think it's Java 16, is a Java new feature in Java 16. It's called instance of pattern matching. It's a binding variable. So this is simplified coding. All right, the object class also has this equals method you can use to compare the two objects if they have the same contents. It's normally it's two different objects. If the same object, they have the same contents, but the different ones. So here you have the two reference variable, object one, object two. So you say object one dot equals object two. So they have them that if they're the same object, they must be equal, right? If they're different objects, so their contents may be the same. And this method equals is defined in the object class, same as toString defined in the object class. So this has this is the by default, it's this. It's in the object class. It's equals means they have the same reference, but when you implement it and so you override the equals in your class, and like here is for the circle, you want to test if the circle have the same radius. So this is override like this. Now we introduce a data structure. It's called array list. We know we use the array to store data. But once you create the array, the size is fixed. Now we use array list. It's very flexible. If you have more elements you need to store it, the size is automatically expanded. So this is the array list, has a lot of features. And this is called a generic type. We get more into generic type in chapter 19. But for now, and you see here is you're going to have the element of the type. You specify type like this is a string, this is an integer, this is other things here, other objects here. So these are the methods here. And so you do, so like creating, so here's constructed creating empty list, and you're going to add the new element to the end of the array list. So this is at the element at the specified index in this list. So there's a lot of methods here. All right. Okay. So this is the animation to show how this each of this method works in this animation. And this is the test code for this. And so what is the difference between array list and array? So this is a table. Please study this table, and this table gives all the details to highlight the difference between array list and array. All right, so there are some useful methods for lists you can use. And like here, if you have an array, you can create an array from array list from the array. So here is this is the using this array start as list here, and then pass this as list and creating array list. So there's other methods here is you can use to get the max and the min and from array list. So here using this java.ut.collection. So for this, and now we write a new stack class. We already have a stack class in the preceding chapter. That's only stack of integers. Now we can write a stack for any type. So we're going to implement it in this way here. Instead of using that array and to store the elements for the stack, we use the array list. It's more flexible. So this is to create a custom stack class for any type. Now, protected data type. So we have public, private, and also there's a, if you don't specify any type, there's a default type, the visibility. And here's protected is used for the in the inheritance. So it's protected member of class can be accessed from any subclass. So if you have this is visibility is protected. So here's an example here. This is a protected here in package P1. So you have this is a class C1, and this is protected. This is the Y. So now in a different package, and you extend C1, now you can access Y because Y is protected. So that can be accessed. Preventing extending and overriding. So you can prevent it, a method from being overridden. You can make the method final. And you can also make a class final. It cannot be extended. So this is the final keyword can be used in the inheritance. And finally, this is a convenient way to write your code. It's using a lombard. It's for generating a boilerplate code using annotations. So instead of writing a lot of code, you can just use annotation here. So this is using annotation and to generate code like a getter and setter. And for this width here, you don't have to explicitly write it. When you compile it, it automatically will generate it. All right, I think that's all for this chapter on inheritance and polymorphism. Thank you for watching. Goodbye.